Welcome to the March 17th SIG Node meeting. We've got a couple items on the agenda. I don't know if everyone is here that's on the agenda. Given the world situation, we'll do our best. As usual, if stuff's not here on the agenda that you want to raise, just feel free to add it and we'll get through it as time permits. So I see the first ask was, it looks like Victor on the video recordings. I actually thought that tooling was auto uploading those. If that's not the case, I will go and follow up on that.
Okay, yeah, it was just, following the link at the top of the thing here where it says video is here.
Yeah.
Yeah, and it's like June or July or something. That's the latest thing there. We've got a couple of members on the team that can't attend from time zones, so appreciate that. Thank you.
Yeah, no problem. Like I said, I thought that the project had tooling now that was all doing that. And I will go back and see what's going on there, or manually at least upload the last set of meetings from this year in the interim. So I'll take that action item. Next item here was around continuing discussion on pod level resource limits. I know I haven't tracked that over the past week, but is the speaker here that want to talk through that?
Yeah, so let me just share my screen. I will update on the context of this, on what has happened in the last week. Let me know when you can see the screen.
Yes.
Okay. So following last week's meeting, I went and I started to review all the things that were raised in the meeting, the interactions with the various other features. And also I gave a little additional thought to the question of whether to do this on a tied to the quality of service functionality or not related to the quality of service functionality. And I would like to update if that is okay. 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 So just a small reminder, the way that Kubernetes, the kubelet right now organizes the cgroups is that there is a top level cgroup under which all of the pods that are in the guaranteed quality of service will appear. Each pod will have its own cgroup. And under that, there will be a container, a cgroup for each container in the pod. For burstable and for best effort, it's similar, except that burstable and best effort live in their own top level cgroup. The current situation in the kubelet is that the pod level cgroup has its limit set for guaranteed every time, and it is set to the sum of the limits for all of the pod containers. And for burstable, also it will be set if and only if all of the containers in the pod provide a limit. The limit that is set is the maximum between the sum of all the container limits and the maximum single init container that exists in the pod. And now if we go on to the set of questions that were raised last time, first question was, what would happen if we set pod limits? What would happen with init containers? So I think if we set pod limits on in the cgroup on the pod level, then it should only be set after the init containers have finished executing. And the pod limit should not take into consideration the limit that was set for the init containers. The reason is that this feature comes for allowing us to share resources between containers. The init containers are going to be run sequentially and they're going to be run alone. They won't be able to share resources with any other container in the pod simply because no other container in the pod is going to be running concurrently with each init container. Okay, please stop me if you want me to answer any specific questions. The second question that came up was, can resources actually be reused between cgroups? So the definition in the cgroups is that resources can indeed be reused across sibling cgroups, assuming that they have been released from the cgroup that was actually using them. So if a CPU intensive process is running in one cgroup and then it finishes using the CPU or releases the CPU, the cgroup next to it would definitely be able to use those shares. That is no problem. The memory issue is a bit more complicated because it is really very much dependent on the runtime being used. So if the runtime is using glibc, you can go into the link, it's also in the KEP itself, will sometimes opportunistically clear memory or release memory back to the operating system. The concrete algorithm is in the link that you can also find in the KEP. Muscle, which is used by Alpine, is a lot nicer. It will automatically mark memory that has been released using the free system call, using madvise and the don't need flag. And that means that if there is memory pressure, then memory can actually really be reused in sibling C groups. I also checked what happens with Go and with Java and with Node.js. In all of these cases, as it is written, Golang will actually also use the madvise system call. So during garbage collector runs, it is possible for memory to be released all the way back to the operating system and then reused in different C group. I took a look at the Java, the OpenJDK Java virtual machine code, and it uses the standard free function. So it actually depends on whether it was compiled for glibc or for muscle. And based on what it was compiled for, that would be the behavior that you would get. In Node.js, there is actually a feature that if you enable it, when you run Node, then it will also call madvise. And then the memory will be marked as available, and you will be able to reuse memory across C groups in that case. Also based on the garbage collector and based on other Node.js internals. Obviously, this really is something that every application would have to figure out for itself where it falls in the memory reuse. And also, if the container is forking and executing an additional process inside of the container next to the main process in the container, then when that process will finish, then obviously all of the memory that it allocated will also be released back to the operating system and therefore will be available for reuse in a sibling C group. Okay, so it is useful, in other words, but it depends on the specific use case. It doesn't automatically follow that if we can define the C group so that memory is allocatable in sibling C groups, that it will actually be used in that way. The next thing is the resource overhead feature. I think if we make one small adjustment to the resource overhead feature as it is outlined in the KEP for the resource overhead feature, then these two features would coexist a little better. And that is that instead of assigning the limit for the resource overhead to the pod level C group, we should assign it to the pause container C group. And the reason is that we don't want that additional overhead to be considered free for use by the containers that are actually running some workload. The pause container itself, the process itself, is not going to be using the memory. It doesn't do anything. So it is a convenient place to just mark that the memory is being used, and the scheduler should probably do the right thing if the memory is assigned there.
I don't think that last statement is accurate. So I do not believe for all the runtimes that would be using the resource overhead feature that there is necessarily a pause container.
Okay, so in that case, what we need to come up with is where we can assign the resources, considering that if it is assigned to the C group on the pod level, then it would theoretically not remain unused. It would be allocatable by the children's containers, the children's C groups. So that's an open item, and we can continue to discuss this and figure out what to do it. Okay.
I guess what I'm wondering is, why is it a problem?
Because if the intent behind the resource overhead is to make sure that the memory is allocated to something that the scheduler is aware of, and then something else is going to be using that memory in addition to the overhead, you would basically be increasing the amount of memory provided to the workload itself and not assigning it to the overhead part of the resource allocation. So the ideal thing would be to somehow make the scheduler aware that this specific pod costs so-and-so more additional resources, but not make those additional resources available to the workload running in the pod. So there's no double usage of the overhead.
Yeah, just the reason I bring this up is like even with pod resource overhead today, usage of a memory-backed volume, we don't have a clear way of separating that among the container and the pod level C group across container restarts.
Yeah, I actually have a separate slide for the memory-backed scratch volumes. So
honestly, there shouldn't have, no matter it is you assign that to the pod container C group, or it is just a count at the pod level, actually it's no difference here. So when you have the memory starvation issue at that pod level C group, you set the limit, you have that one. Anyway, the right, C group will kick in, and will based on our design, they will decide how to reclaim, kill some, reclaim. They could kick out the reclaim thread, and they could do some like the push down to the IO, or they maybe just kill something. Then we will base on the score to kill. So our POS container already by design for our Kubernetes management, that POS container actually it is in that given container actually should be supposed by design it is last one to be killed. So I don't think about it. There's the problem. I personally think about this is a little bit over design. And the last meeting I did mention that pod overhead actually make the feature you propose here actually one step forward, like make it is like possible. So it's not the complexity actually it's help you solve some issues. And although I don't think about there's any concern here. If there's the memory starvation at that pod level C group and kill many of the things, I don't think kernel will kill the POS container unless kernel have some bug, because they would like to kill some container based on WOM score and also based on how likely they can reclaim memory. And so they will decide it, do the best effort, decide to kill something.
Yeah.
I have a question.
Yes.
Are you proposing that the pod overhead is added to the pod level C groups that you would define, or that we would only use the pod level C groups and pod overhead would be, are you sort of suggesting that pod overhead is a separate category of accounting?
So I think it is useful to add that overhead to one of the C groups. I'm just a bit leery of adding it to the pod level C group. Because if we add it there, then I'm afraid that it is going to be utilized by, or doubly utilized, once by the runtime itself, and then once again by something running in the pod. So I want to assign it to a C group where it's not going to be doubly used also by the workload in the pod itself. But the other thing is, this is, the resource overhead is a feature that actually only uses the request, right? Not the limit, because the limit isn't really relevant for the scheduler. The request is being used by the scheduler.
So I think the idea is that what the scheduler uses and what the C groups actually reflect should be the same. So we increase the requests for the purposes of scheduling, but then also add to the requests and limits of the containers so that that extra CPU and memory exists. The idea is like I should be able to run container A on any runtime class if it uses the same amount of resources. So we just have to budget in there that extra piece depending on what resource class it gets assigned.
The thing is that if you define a limit in a C group, that doesn't automatically allocate the memory to that C group. The memory will only be allocated once something actually tries to allocate that, something in that C group tries to allocate the memory itself. So for the request part in the resource section, the scheduler obviously will take into consideration the overhead that is defined in the resource overhead. But even if you added that same amount of memory to the limit in the C group, it still doesn't mean anything. It would only mean something if that memory was actually going to be used. So the container runtime, the shim itself, or I don't know, the VM, if you're talking about kata containers, should also be in a C group and should also be considered as part of the C group where the memory is being accounted for. Do you understand what I mean?
Yeah. I understand what you mean, but I just want to point out, if the POS container or whatever runtime shim and the container die, the entire of the pod should be terminated.
Yeah.
So no matter where you charge that limit entry, and it doesn't help. And your statement you mentioned here, you want to guarantee the resource, the pod level of the resource can be shared among the container, but excluded the POS container or other runtime shim container. Which it is, to me, is like the logical here actually is not correct, because any of those runtime shim containers being killed, entire of the pod will be terminated.
Yeah.
You need a guarantee there. So basically what I want to say, you said, oh, we need to set that limit. That limit, actually, even we set that limit, not guarantee that the container, which is the fundamental container, can be using all the resources. And only is just make sure there is not behavior wrongly. We are abusively using other containers' resources. So I don't think about that. This feature actually have to cause problem for any of those what you propose here. Okay.
So okay. If I understand what you mean, then this feature, or the feature that I'm trying to propose here, only affects the limits. It doesn't talk about the request. The request, which is handled on the scheduler level, the resource overhead has no negative interaction with this with the pod resources limit or resource sharing functionality, and it doesn't matter. And maybe the right thing to do would be to not even increase the limit for the pod or the POS container at all, since the memory isn't going to be allocated by something running inside of these containers, these C groups, and the memory shouldn't actually be considered something that they might add to their limit.
So
yes.
This entire feature doesn't work with kata containers, right? And then I don't know how it would interface with things like gvisor, but it seems like
yes,
where there's a hypervisor between the container and the host, pod sharing resource limits is basically a non-useful feature, correct?
I'm not sure, because if you consider that even if you're using, say, something like kata containers, a block of memory is assigned to the VM itself, but then the VM in kata containers would actually launch its own internal, I think it's container D or something like that, using some sort of CRI, and it would also create additional C groups inside of that VM. And it would still make sense for it to be possible to share resources between those internal containers, even though the total budget of the VM is really set and will not change. That is okay.
So that's why it confused me earlier, because I believe both David and I suggest you take that container runtime share or POS container, their request is power the pod overhead, what we described there, and add to what the pod level of the limit at the top level. And then you cover those kind of these cases. Then we don't need the over design, say, oh, how to guarantee POS container, or maybe container sham using more the resource specific, and or maybe like the guarantee their limit. So I think if that's the cases, I think we cover what the resource overhead pieces. So I'm confused, but you disagree on that one.
So my problem with that is that even if you grant that overhead to the C group on the pod level, the fact that you've increased the limit on that C group doesn't mean that that memory is actually going to be allocated. So it just means that this entire pod can now, for example, instead of being able to use the 1 megabyte that the pod itself requires, it can use the 1 megabyte plus another megabyte that is specified in the pod overhead. But it doesn't mean that it is actually using that additional 1 megabyte. So if one of the real processes in the workload that the pod is managing tries to allocate 2 megabytes of memory, that will work. The limit will make it possible. But in case we're using the resource overhead scenario, basically that means that we've used that additional 1 megabyte twice. We assigned it to the pod in the hope that it would be allocated to the overhead. The overhead might be using it because the overhead is probably not running in the shim is not running in the same C group.
It should be running in the pod C group. I think that's the thing that you're missing here, is that the design of this is that there are per container, or sorry, per pod processes that we want to run together with the containers, and that's going to take up extra memory.
So in that case, that is a lot better than what I thought. I missed that. It still has a potential problem, and that is if the shim is not going to allocate all of its memory up front before it starts any of the containers that it is going to manage, then there is a race condition here, and it is possible for the memory to be allocated by one of the containers that are running under this shim.
Yep. So for those sorts of problems, that's what Don was talking about earlier with the killer. If it does eventually try and allocate that memory, it'll trigger an and because of the settings we've configured, the user process will get kicked out, hopefully, instead of the overhead process, if they're actually two different processes. I don't know how that works with Sandbox. That's the overall design.
In that case, I completely see your point, and you're right. There should be no issue, and this feature is these two features interact nicely. Okay. So the next difficult point is what happens with TempFS, or memory-based scratch volumes. And the problem here, I actually went into the documentation in the kernel, and I went into the source code itself. The problem is that memory tracked by TempFS is actually considered a shared memory page. So files that you create there are considered shared memory pages and are tracked by the memory driver in the cgroup subsystem. And the way that it works is that the cgroup that first touches the memory page is the owner of that page. So once you've created a file in one of the containers, that memory is allocated to that container and can never move. There is one way that memory can be moved, and that is if you go through swap. But since Kubelet right now doesn't use any swap, effectively in Kubernetes, once a container creates a file in a memory-based scratch environment, that's it. That memory is forevermore, and until the file is deleted, considered part of the memory of that specific container, or that specific C group. It will not be able to be shared, or you will not be able to gain anything by having a pod level definition here.
Yeah, all I'm saying is what happens is the writing container gets charged the memory, but then if that container restarts, obviously the file remains, and the charge just goes back to the pod.
And the charge, yeah, that is the case. But if the pod is restarted, I guess that would also mean that
if the container is restarted is what I was referring to. If the pod's restarted, then
because if
the volume isn't torn down.
Yeah. So yeah.
Nor is the pod C group torn down.
Yeah. So if the pod is then restarted on the same node, then you would still have the content, and that content would probably be allocated to the pod level C group, which is actually okay. I think it's not.
Derek, shouldn't you think about this is better than today? Because today we goes to top level.
I mean, all I'm saying is it's no different.
It's no different.
It's no different, but think about if it is the guarantee job, and it is guarantee job, and that if without of the pod level limit, and without actually today this is still same to today. Even today we already have the pod level C group, even we don't have the limit. So it goes to the pod level, but earlier of the Kubernetes the memory design, actually we don't have the pod level, then goes to the root, which is a big problem, right? So you basically, those kind of messaging, if without of like the root level of the memory pressure, we may not claim those kind of things. So if effectively maybe hurt other common workload performance. So I basically think about this is not a problem. We charge to pod level C group and it's not a problem actually. And we will make those memory pressure to the local region instead of effect of the per node performance.
Yeah.
Yeah.
The only, yeah, I don't think this is any change in behavior for today. I think the thing something that can happen today is a container keeps writing to a memory back volume and then uses all the memory to that pod and then actually can't restart that container.
Yeah.
I want to clarify a little bit. Actually,
this situation, you'd still have that same problem. So there's really no difference between today and with this feature on this.
I want to clarify a little bit. There I have just a slight difference. So initially we don't have the pod level. We don't have that limit. So then basically it's not the kernel won't effectively reclaim until we have the root level, have the memory pressure, then they will reclaim. And that will actually, once the kernel start those reclaim, and actually definitely will affect everybody's performance. But this one actually is original because we have the pod level of the limit. So we may end up to like the container die and charge to that pod level. And then we may trigger some pod, the memory pressure at that particular pod level and trigger off the C group reclaimer instead of global reclaimer. So that's why that's a little bit the subtle difference we have.
That doesn't cause the file that's consuming that space on the volume to be like eliminated.
That's true. That's true because it's the yeah.
I think it is an accounting difference. It might be actually a little better because it would mean that if the pod is limited, then you won't be able to swamp the entire node once the container that wrote the file goes away. And then if there is still enough available resources on the pod level, then a new container that is being created that has specific limits would still be able to start. So it might, in some cases, I mean, it is a bit contrived. It might actually help. So I think it's not very different than what we have today. With that statement, I completely agree. Okay. Can I go on to the next item?
Yeah, go ahead.
Okay. So as far as I can tell, there is no harmful interaction with non-uniform memory architectures. As far as the C group is concerned, the process might be, right now we don't support, I think, the CPU set C group. So there's no pinning of specific processes to specific CPUs in the NUMA set. But even if there's,
if there is a CPU manager active.
Sorry, I didn't hear.
We do support that.
Oh, we do support that. It still doesn't matter because in the end, the memory C group doesn't care. So memory is memory. It doesn't matter which group of processors is actually using it. It's accounted in the same group. And as far as any additional C groups that we might be able to use, I don't think that I don't want to tackle them in this specific cap. So right now, I only want to touch memory and CPU. But if we were to add support for them in the future, I don't see any inherent problem here, unless somebody can enlighten me.
Yeah, Derek, I think you had asked, would there be any impact here on Topology Manager? And I brought it up in our weekly meeting with the rest of the group. And we looked at it a little bit, but unfortunately, none of us have really dug deeply into this KEP. And I think it would be good if we, you know, on the Topology Manager side, took a closer look at this, and we just haven't done that yet.
Okay, so if you want, I'm available both on email and on Slack if you need my input for anything. I'd be happy to help.
Thank you.
Okay. So I changed my mind a bit relative to last time that we discussed this. And also based on comments that were put on the issue in GitHub. My thinking now is really to put a resource in the spec level. And that way it would be at least easier to explain exactly what the expected behavior is. That is the biggest advantage here. The second advantage would be that it is not therefore tied anymore to the quality of service mechanism. It works the same regardless of which quality of service your pod is. With a small caveat that for guaranteed pods, the pod level C group doesn't actually mean anything, since the request and the limit are, you're never going to be able to use more than the limit for any specific C group in any specific container. So if you defined a resource on the pod level that is higher than the sum of the limits in the containers, it wouldn't matter. And if you define something that is lower, then basically you're just making sure that you don't get all the memory that you want in the pods, in the containers themselves. So for guaranteed pods, it really doesn't help. This is more a feature that is relevant or useful for burstable or best effort pods. Now, this mechanism is obviously an opt-in. If you don't specify the resources on the spec on the pod, then nothing changes. You get the same exact behavior that you get today. Yeah, that's it, I think.
The issue I'd see there is in earlier meetings, there are folks who are trying to do in-place resource resizing without restarting a pod.
Yeah.
And doing vertical pod autoscaling around that. If we added a pod level resources section, we'd want to clarify what can be mutable post pod creation, and then what would be the intersection of that and the VP.
Yeah. So from I tested this a little bit, and as long as the memory is not actually being used by something in the C group, you can both enlarge and diminish the limit. So for example, if you defined a limit of 128 megabytes and you're using just 64, you can easily reduce the limit to 64. And obviously at any point you can increase the limit to any number that you want.
So,
and that works.
So I want to ask like a practical question, if that's okay. So you do pod level resource limits, and then a user sticks a couple containers in there that are using a Go runtime or a JVM as their underlying runtime. And if I specify no container requests on those individual containers, when the container starts and says, oh, tell me how many CFS shares I have, like the default behavior of the JVM is going to say, oh, I have 2 min shares, and so I'm going to tune my garbage collecting thread to 1, and the user has horrible performance. Same thing would happen on Golang. And so like one of the things that I'd struggle with a little bit here is like if you add pod level resource requirements and then assume you don't set anything on the container level, how do we make it that application runtimes that use this actually do the right thing, or will users just be chasing out how to tune their JVM or Golang GC behavior in response?
Yeah, so that's a valid question. Obviously, I don't know, so it really will depend on the application itself. As long as the option to do something like this is not available, nothing will change. For Java, for Golang, maybe it is possible to somehow be aware of the real amount of resources that you are going to be using. I mean, this is not really
today. Like so, today the JVM will start and see the shares available to the C group, and then or the CPU sets assigned to it, and then try to tune GC threads to that. But then, you know, there are other ways we could get this down into the container environment. You could do the downward API. And so I was just struggling a little bit where it's like, how would we make the application aware of this to try to do the right thing? Or would there be a downward API thing? But like the more the more you move one layer of abstraction away, the less things default to just do the right thing by default.
Yeah, but also for the JVM and for Go, it is possible to override and not use the server ergonomics feature, for example, on the JVM level.
Yeah, it's just the thing that I also know that no one knows how to do really in practice. And so like today, if they were saying, I want one CPU, they get 1024 shares, and then the JVM will do.
So maybe for this specific use case, the opt-in, this is somewhere that you would not opt in to use this mechanism. This is not something that I would enable by default. I would only enable it in use cases that really require it. And in those use cases, not being able to do something like this is really limiting.
But it's almost contradictory to the idea that like, I don't want to think about resource tuning on the container basis because I just want to set it at the pod level when the outcome is that you're going to have to be tuning your garbage collecting threads on your runtimes very granularly. It's almost like my app, the pod author doesn't want to care, but the actual user writing the app definitely will care.
Yes, exactly. I think that I raised the same question last week. I think that all those kind of the interactive with these existing features, I don't have big concern. Like you saw me defend a lot of things. I don't think it's a problem. My problem it is how this using this feature. And in the past, the people propose the pod level, even ourselves, and a couple times on the pod level request and limit. The problem it is, especially today, like the sidecar container proposal, all those kind of things, we basically, I think I used in the term last week, reverse priority. So you have like an application you are running. That's the most important thing. And then you are using some sidecar container or help container to help you. And those people deliver those sidecar container or helper container, logger container. So they basically just say, okay, I don't care how much the resource usage. You go figure out the pod level. And you, at the pod level, you basically guessing each of those helper container and the resource usage, and plus your application, and then add at the pod level. You end up like, oh my God, and your real application will behave it. Then you have the limit because you measured, but all the rest of the stuff, you have no idea. So they may overusing, they may starve your application completely. So that's kind of for me, this is why I think it's like a little bit resource reverse priority. So we basically need the application. Our job, Kubernetes, do a lot of things. It is help the CI/CD, help those developer, application developer. But actually this proposal could be impractical in reality, could be make their job is much harder even. That's my concern, because it's kind of we remove all those kind of the hard requirement for people provide services and go through the sidecar container, but they don't take care of the resource management. And but the real people, not real people, everyone is real, and the people developing the real application actually have all the trouble, and the people deploying those applications also have all the trouble. That's my concern. I think this is the biggest concern I raised the last week.
Okay.
So all the other technology and the interaction, honestly, we did this before. I just want to share with you in Google, we have this feature before.
On a very human level, right? This is a timely topic. I think those on the Red Hat side know that we spent a long time talking about this earlier this week. Is just like, I think when you first presented the feature, you were doing an IDE in a pod, and I'm just curious, like, is there Java there, and how do you tune it, right? Like, what type of guidance would you give to people? Because these are like the real world practical things that like we were struggling a little bit on the Red Hat side when we're thinking through like, what should the right JVM behavior be? What should the right Golang behavior be? And I'm sure Google and others are having the same discussions.
Okay, so I can tell you from the IDE that we're developing that we do have Java-based tools in that IDE. For example, one of the things that you probably want to run in an IDE is to run the Java compiler or Maven or any other related tools. It's a bit different. So for those use cases, since these are short-lived processes that you're going to run inside of the container and they're going to consume some amount of memory and then they're going to go away, everything that they use will be deleted, and I don't actually care about the ergonomics of it. So if it thinks that it has one CPU when actually it has half a CPU, or the other way around, it doesn't really matter. The process is going to run for a really short while, and then it's going to go away, and it's not going to be a problem. On the other hand, if I don't, if I have to specify a limit for each and every sidecar that provides each and every tool, then one user is going to be very upset that his program isn't even able to compile, because the compiler that runs in the sidecar that his tool lives in requires more memory than I was able to pre-allocate to it. And I definitely can't
Is it fair to say that like memory is your main concern, but like
yes.
the fact that the compiler ran super slow is not your concern?
So the memory is, first of all, the main concern, because the memory is not a compressible resource. For short-lived Java programs, there is going to be some inherent unstableness, maybe, for the way that it considers how many threads to run or when to do the various housekeeping tasks, but it's really not that noticeable, at least for my use case, as far as I can tell.
But if like memory is the thing you're truly concerned on, like should we scope this to non-compressible resources?
Okay,
Because
that's
otherwise, if you make this popular for things like CPU, like I think every Java workload in the world or every Golang workload in the world would be struggling for what should the Kubernetes default be?
Mm-hmm.
at least for my use case. If we support memory, then that solves 90% of my problem, maybe even the entire problem. So that's also fine with me.
Can I ask you some question? Actually, the sounds like you really have the real time, like the real business concern to enable this feature. How hard for you enable your feature through some daemon set?
Sorry, I couldn't understand.
You can honestly, without enable these features standard for the Kubernetes, actually you could enable what you propose here, and through some other way. You could have the daemon set, and
Okay.
because we already have like the cost C group, right? We already have like the all those like the top level of the guarantee, top level the burst and best effort root C group. You could have the daemon, and you could watch off the API server. You could just set update of the C group, pod level C group. And once you see this is landed, instant change of the Kubernetes. Have you ever think about that way?
Actually, we have not tried to manipulate the C groups behind the kubelet's back, so to speak. I didn't think of doing it. I could do this as in some way. The question is, how would it interact with any future development of the kubelet? So I would rather solve the problem as best I can correctly in the community, and not have to maintain my own daemon set that is doing something that might not be entirely correct and might not continue working in 2 versions from now for Kubernetes.
The reason I propose that way is just because for us, Kubernetes, we want to help everybody. So it's the standard is much higher, and but sounds like because for the particular vendor or not like the internal using, you may have more flexibility, because you like, especially for internal infrastructure, you could push it, and your company or the application developer follow certain rules, right? Like the Java application, how to do, and the Golang application, how to do, and whatever things you could define based on the optimize that. But for open source Kubernetes, we really want to best result. A lot of time we couldn't, obviously we made a lot of mistakes. But what Derek, David, and I earlier mentioned, we have the concern because people might abusively using this feature. So this is why we give you a lot of question. It's not a lot of what you propose is makes sense, but it's just our concern. It is different use cases, different things. It may people highly possible people might abuse this, and so that's why we concern. But there's the other opportunity. Like if you can prove in-house, then maybe you you have more come back to us and then make this is more generic solution. But so far, a lot of questions we asked, especially for the practical question we asked, and we don't know. And based on your response, you also don't know because you haven't tried that yet. So this is why we have a little bit higher bar compared to previous, because Kubernetes is widely used by, adopted by many people, many companies. So that's what I just threw this idea to you.
Okay, so the way forward, as far as you're concerned, is that we should try to implement something like this that goes behind kubelets back, so to speak, and manipulates the C groups on the operating system level, and then see how it behaves and see what happens, or?
I mean, I think
Okay.
that's one way. I'd ask some other questions before you jump to that. I get why Don asked that. So like, I definitely appreciate that. Like, I don't want to have a dual writer problem for the C group in the future either. One of the things that wasn't clear to me in your use case though was like, is the deployment of Kubernetes that's running your use case only running your pods, or are there other pods that wouldn't want this capability? Like we could explore like a node level option that says, enforce pod level boundaries without putting it in the end user API. But it just requires you to then deploy your application to nodes that had that enforcement option on.
That is an option for me, but the question then would be, how would you define what that limit is for each pod?
Yeah, I forgot that because you don't want to specify it on a per container basis. Yeah, I apologize on that one. It's too much in my head, but yeah, maybe that's not the greatest option.
So Derek, you don't want to dual writer, it's just because the C group version 2 concern.
Yeah, like, so CGroups v2 will come out, and then like you'll have multiple people writing to the same slice, essentially.
Would it be an option to enable something like this behind a feature gate in alpha level, and then that would give the opportunity to try it out and to see what happens? And if this is something that is not practical or something that is being abused, we can always remove alpha features, right? It's not.
Here's the one concern. Actually, this is exposed complexity. Like for example, at least the complexity for VPA feature.
For
VPA, vertical pod auto scaling, definitely have we just settled down about those kind of things. Immediately this way expose the new complexity to that feature. This is why alpha, even like alpha, it is good idea. And the only reason hesitated, in the past we did say, oh, okay, alpha feature, gatekeeper. But this one actually, because interactive with many other feature and have the complexity. So it's not like the one gatekeeper can solve that problem. Yeah, that's tough part.
Okay, so what is the way forward in that case?
Alexandra actually proposed something, experimental annotation as a trial.
I guess the moment we put this in there, you're going to use it. That's the horror of what's in front of me here, right? Is like we've done these studies on like who uses alpha features in production, and then when you say, oh, it could get there and then go away, like if it goes away, you'd be right back.
That's it.
But the converse of that is that if it is being used, then obviously it is useful and it is practical to use it.
So that's why earlier I suggest the separate daemon site, so they can build in-house. And but if they prove it's really useful, and they also have an incentive to come back to upstream because they don't want to maintain those things. So we can have the more like the in-production use cases to back up that one. So right now we have a lot of questions and actually no answer, right? In the practice, actually, even I have like the production experience before, it's hard. And But still it's not really, because Kubernetes design actually is different from above Borg. So certain complexity from Borg actually is not necessary here. And so that's why I would suggest a separate daemon set before we have the Kubernetes move to the cgroup version 2. And
even with V2, I think, Dawn, like we're not writing a memory limit if it's not, like, we're not changing the behavior right now in Giuseppe's code. So like the daemon set probably works, but you just want that daemon set to track an annotation on your pod instead of looking at the per container things. But then I'm trying to think through where that would die down. I would try that and report back and see what falls apart. I can't think I know everything in my head right now.
Yeah,
Won't this just fight with the kubelet? Or is
I
the
think
idea
so.
that, I thought the kubelet was already setting these values. I guess
So
it,
what would happen is exactly that. The kubelet would set these values, and then once the pod is up, then this daemon set would have to override that. And I'm not sure what the interaction would be between the two things.
Well, it wouldn't write memory limits, right? And that was your use case.
Yeah.
The other question is, say I do manipulate the cgroup levels, how will that affect the scheduler? If I manipulate the cgroup levels from outside of the kubelet, will the information that kubelet provides to the scheduler with regards to the current requests and limits, will that be affected in any way?
The scheduler
so
don't
You
use
need one pod to act as, I'm sorry, you would need one container to act as your like resource reserver.
So scheduler don't using limits. So you only set up limits there.
Yes.
Yeah. So I understand what you concern. You concern about the Kubernetes maybe override what you're there. So you can watch API server, and once the Kubernetes, you could after the Kubernetes, how I can say. Now I'm thinking about if the actual pod status report back, and actually that's the good way you set the limit, because you already have the pod container and you already created off the pod level cgroup, and you have the sandbox and create it. But we don't have that one. So you could have like when Kubernetes first report pod status as the running, then you can update that one. Then from that stage, Kubernetes won't override.
Okay.
Right.
So
the
if I
only
wait until the status is running, yeah.
Only things in the long run, once we have the VPA, so they may be updated. So you need to watch of those kind of field change. And another concern it is because you may still have the problem and during the container startup time, right? So sometimes if the container startup time have a lot of burst, and then you may not, this feature not help you at all. And but I think you are okay, because earlier you are talk about the init container. You say, oh, we anyway init container already finished running, and then so I think the startup, the burst there, maybe it's not concern for you. So you can.
Yeah, the startup isn't a concern. I think I agree. My problem is mainly what happens after everything is up. So it's a very burstable workload, and the bursts are what is causing my problem. Not the startup. The startup is actually very deterministic. I know exactly what the memory usage is up to the point where the user starts to actually work.
Yeah. I think Alexandra, you have other comment. Do you want to speak?
Yeah, I wanted to speak, but I didn't want to interrupt. So I was just thinking, what like introducing this fields in the pod spec, like it's shown on the slide, it also will have other features. So for example, like some time ago, we discussed about the shared devices within the pod, like RDMA. So when we like allocate one device and then it's shared with multiple containers, and this syntax will help it.
Yeah. Yes. So is that okay? We can make the please have some other suggestion to move. What's the next step? Potential next step, and yeah, besides of the separate of the daemon side for try this in Leon's company first and got the gain first hand of the experience, then come back, talk. Any other suggestion?
Okay, so I will proceed with the daemon set, and I will report back once we've had some time to see how this interacts with everything.
Yeah.
Thank you.
May I suggest you summarize what we discussed and what's the next step at your CAP, so we
Yes.
can easily refresh our memory next time. And also, can you add your slides to the today's meeting notes, because your slides are really good. And so we can come back next time when you came to talk to us again. So we have a way to track those things.
Sure thing.
Yeah.
Thank you.
Thanks.
Bye, everyone.
Yeah, I know we're out of time here. I know Mernal, you had an item afterwards on the agenda. We can follow up on Slack or drop a link.
Sure. Sure. Yeah. You can follow in Slack. Yeah.
And also Michael Brown, I have the proposal. Also, he have the CAP there. So Michael, maybe we can move this one to next week. Is that okay?
That's okay. Works for me.
Yeah, thanks.
Okay,
Cheers.
bye all. Thanks. Stay healthy.
Bye. Everyone stay healthy and stay happy. And thanks. We fight together with this virus. Bye. See you.
Cheers.
Thank you. Bye bye, everybody.
Bye, guys.